I'm Valeria Esparza, and this is CP1 project video. Me and Melissa decided to do this separately and submit our own videos because we weren't able to get together, but we still wanted to do the project correctly. So we'll both be submitting a video. So CP1. We were given MP5, which is using appropriate tools strategically in math. So using tools, I would say nowadays is more like technology based, like teachers use smart boards, overheads, Google Classroom applications with their students. I've seen a lot, and a lot of stuff is online, like Mathia, Lexia, several things are online. Other tools can be like counters for elementary or for kinetic learners that need more hands-on stuff, and finger counting methods like the 9 rule and just like different things that you could learn. And we chose the Pythagorean theorem because it's introduced to 5th graders like at the end of the year, and then it's really delving into in the middle school grades, and then later added to in high school with cosine, sine, and tangent. So we thought that'd be a good concept to introduce and to talk about. So Pythagorean theorem. So we started with, why is the Pythagorean theorem important? Not only can it help you find the third side length to a right triangle, but it can also help you find the missing side lengths to squares and rectangles when the triangles are pushed together. The Pythagorean theorem can help build rectangles and squares. So this would be like just a little why is it important for the kids so they understand like how can this be important. It also says right here that builders use the Pythagorean theorem to help keep right angles and build houses, decks, buildings, and other things. So like construction workers, architects, several careers use the Pythagorean theorem, and it's important for the kids to know that it can be used outside of school. The history of the Pythagorean theorem. So this one is just so like the kids know where it comes from, where the word comes from. So Pythagoras was a Greek mathematician known for formulating the Pythagorean theorem. He was also a philosopher who taught that numbers were the essence of all things. He associated numbers with virtues, colors, music, and other qualities. He also believed that the human soul is immortal, and after death it moves into another living being, so sometimes an animal. So this is interesting, I think, for students to know where it comes from and actually have an idea of who he was and where it comes from, I guess, originally. So how can we find a missing side on a triangle? So this is like an example for the students to see how to actually use the Pythagorean theorem. So this would be like a lesson. So like I would introduce the rules, which rule number 1, for the formula to work, you need to know 2/3 of it. This is, I know, not required in all grades, so like for an introductory, I guess it would be a good rule, but later on you can like be missing pieces because you know you have sine and tangent and different aspects of the Pythagorean theorem. So 2/3 would be like A and B, not C, or C and B, not A, you know? So rule number 2 is C is always the longest side of the triangle. So C is the hypotenuse originally, but it doesn't mean that you're always looking for C. Rule number 3 is you can work backwards with the formula. So you can be missing C, but you can also be missing B and A. Just whatever you're missing, you have to solve it as if it was missing, and you manipulate the numbers differently. So you subtract or you add differently, depending on what you're missing. So procedures would be, number 1 would be to identify your A, B, and C. So know what you're working with. So the example, it says B is 8 feet, and A is 6 feet, and C is obviously missing. So I would start by plugging in A as 6 squared, B as 8 squared, and then C is still C squared, since we don't know what it is. Then we would move on, and you see it says solve the exponents. So the 6 squared becomes 36, and the 8 squared becomes 64. You still have the example shown right there. about B being 8 feet and A being 6 feet. The third procedure would be add like terms. I chose add like terms because sometimes it can have actual variables, and you want to know that you want to add your x's and your y's or your z's or whatever variables are the same. So 36 plus 64 equals c squared, and 100 is 36 plus 64, which is c squared. And it shows the kids, like, it's an easy example, which doesn't mean they will all be perfect like this, but it is a good way to show them about Pythagorean theorem. Solve for c using square root. Square root is where it's like tricky because some kids may not know the concept well enough, but once it's known well enough, you understand that the square root is just the opposite of squaring, or exponent 2, the exponent of 2. So the square root of 100 equals c squared. So they must understand that the concept of what you do to one side, you do to the other. So to get rid of the squared on the c, you must do the square root of 100. So eventually c ends up being 10. So that means the hypotenuse side is now c equals 10. This is a video summary on how of the Pythagorean theorem, another way of learning it. So you can watch that. And this is the SIOP model implementation. So we prepared a lesson, so I put a plus by that. We built background on it, so we introduced the Pythagoras and why it's important. Comprehensible input. I discussed ways of how it's used in elementary and middle school and high school levels. I used some strategies to show like examples of how to do the Pythagorean theorem. Interaction. I created the video, and I would eventually create like note pages for my students to jot down notes as I go on the PowerPoints. Practice and application. I think this one means more like homework, I guess. Like they practice it so they become efficient. So maybe I would have someone come up to the board and like present a problem or solve for C or solve for A, so they understand the concept of like working backwards, you know. Lesson delivery, being like inclusive. I guess if I were in a classroom, I would be making sure everyone was listening, or like seeing if everyone was taking notes actually. Review and assessment. At the end, I should have added something like, now try this, or like, you know, like try a different problem, a way to know if they actually learned it or understand it, or what I can do to help them next. But that's something I'll be better on. So thank you so much.